Complex Numbers and Polynomials by Drew Johnson and Brandon Hewgley. Imaginary. Every complex number has a form of a plus bi, with a and b real. I is a complex number, while I squared equals -1. And then I cubed will be the negative square root of -1. Adding complex numbers. When adding complex numbers, first add the real parts together, then you add the imaginaries together. So for our first problem, we have 4 plus 3i plus 6 plus 2i, which will give us 4 plus 6 for the real, and 3i plus 2i for the imaginary. Next, and then when you get your total, it's 10 plus 5i would be our answer. For our next problem, we have 3 minus I plus 4 plus 5i. So we have 3 plus 4, and we have negative I, because the negative comes over from the thing from 3 minus I, plus 5i. That gives us 7 plus 4i for our total answer, for our final answer. Subtracting complex numbers. When subtracting complex numbers, you first distribute the negative to the second complex number, and then you add them. So we have 5 plus 2i minus 3 plus I, which gives us 5 plus 2i, and then you distribute the negative, so you get -3 minus I. Then you add them, like adding complex numbers. You combine not combine like term, you add the real, 5 plus 3, -3, and then 2i plus -I, or 2i minus I, and you get 2 minus I. Oops, messed up there. For our next problem, we have 4 plus 3i minus 7 plus 2i. So first thing you do is bring down the 4 plus 3i, then distribute the negative amongst the complex numbers, and you get -7 minus 2i, and 4 plus 3i. -4 plus -7 and 3i plus -2i. Giving us -2 minus I. Multiplying complex numbers. In order to multiply complex numbers, you need to FOIL. So FOIL for first, outside, inside, and then last. So first thing you need to do, 7 times 3i for first, or 7 times 3 for first, which gives us 21. Then you do outside, 7 times 2i. And then you do inside, I times 3 gives us 3i. And then finally last, I times 2i, which gives us 2i squared, which makes our final answer 21 plus 14i plus 3i plus 2i squared. And you can combine like terms, 14 and 3i, to get 17i. Second, we have 4 plus 3i and 2 plus I. And FOIL, first, outside, inside, last. So we have, first, we're going to have 4 times 2, giving us 8. Outside, 3i times I, giving us, 4 times I, giving us 4i. Inside, 3i times 2, giving us 6i. And last, being 3i times I, giving us 3i squared. Which gives us a total of I plus 4i plus 6i plus 3i squared. Sorry, I keep on yawning. Conjugates. What is a conjugate? The conjugate of a complex number has the same real and imaginary part, but has the opposite sign in between. So, what is the conjugate for x plus 3? It would be x minus 3. And when you multiply a complex number by its conjugate, it gets rid of the imaginary. So we have x, or 3 times x plus 3 times 2, giving us x times x plus x times 2 plus 3 times x plus 3 times 2, giving us x squared plus 5x plus 6, and that's our total answer. Adding polynomials. Adding polynomials is just a matter of combining like terms with some order of operations thrown in. So we have 7x plus y plus 4x plus 2y. So we have 7x plus 4x and then 2y plus y. And that, let's first do x. So we have 11x plus 3y. That will be our final answer. And here's another example of what we just did. Subtracting polynomials. Subtracting polynomials is quite similar to adding polynomials, but you have that pesky little minus sign to deal with. So what you must do is take the negative through the parentheses, shown there. So first what we have to do is 9x plus 6, you keep that, minus 4x minus negative 2. And that will give us 9x plus 6 minus 4x plus 2 for a total of 9x minus 4x and 6 plus 2. So we get 5x plus 8 for the final answer. Multiplying polynomials. To multiply polynomials, use the distributive property, then you multiply them. So we have 6 times x, which gives us 6x, and then 6 times -4, giving us -24, and that will be our final answer. So, yeah, 6x minus 24 is the answer, and that will be it for complex numbers and polynomials. I hope you enjoyed our video, and thank you.